everyone. So officially, let's start with the workshop. This is the Python for OR. Just from now on, the workshop is gonna be offered in English, just to let you know. And first of all, let me introduce you to your presenters for today. We have Gabriel, Oiku, and Christina. Gabriel is a PhD student at Université de Montréal. Oiku is a postdoc at UQAM, and Christina was visiting us last semester. And right now she's a PhD candidate in Germany. So without further ado, let's start with our workshop.
Thank you for the introduction. I'm happy to be a broad part here because it's 6 hours later, so it's an evening activity for me to present this to you. I'm very happy that my friends in Montreal asked me to be with you today, and I will start sharing and I will start the presentation and hand over to the others later on. So let's share. I hope you can see my screen now. Somebody please nod. Yes, perfect. Okay, so as Rose already introduced, this is of present Introduction to Python to you as the first part of a 4 series about Python operations research. So what are we actually doing here? This introduction is taken from the Jupyter notebook that we provided you yesterday, and we think that the Jupyter notebook is a very good interactive process that actually enables you to be able to work with Python, to develop, document, and execute your code. It's very easy to communicate your results, as well as it's very easy for us to communicate our approaches and how we actually want to guide you through the process of learning Python. So you will be able to follow the Jupyter notebook, which has very good features in our opinion. So you can edit the code in your browser, you can automatically highlight the syntax, you can execute your code from the browser as well. You can display your computational results with very nice representations. You can basically do anything you want. You can use LaTeX to visualize your mathematical equations. You can also edit rich text with the Markdown language, and you can also just in a very simple way use the user interface. Okay, so this is just an explanation for how the Markdown cells work, how the Python cells work. So you will basically figure this out automatically once you know how to deal with the Jupyter notebooks. But if you want, you can refer back to this part or to the top part of your Jupyter notebook to actually know what's going on. Now let's get started. Why are we talking about Python? And the first step, what is actually Python? Python is an open source, high-level general purpose programming language that was created by Guido van Rossum in 1991. And people say that it was named after Monty Python. Basically, you can use Python for anything. You can automate tasks, you can calculate, you can access databases, you can download information from the internet, and much more. Obviously, you can also use it for operational research. Why you should learn and use Python? In academia, Python is appreciated as a relatively quick, simple, well-documented, and intensively used programming language. This is a good thing. In a way to enable you to be actually able to do something while learning it. So you don't have to be a professional Python coder in order to use it for your purposes. And then the well-documented and intensively used part is also very good, because you will find some other person who has the exact same problem that you have on Stack Overflow or in a Google group or on the Python help sites. So that will be your friend. Stack Overflow will be your friend if it's not already. And then additionally, as I already said, you're able to integrate Gurobi and Cplex optimization software into the Python code, but more about this in a later stage of our presentations. So in the second and in the third installment, we will be talking about integrating those two. In practice, the usage of Python is growing rapidly. Sorry? Is someone wanting to say something? Okay. No. Sorry, I got confused.
No problem.
So yeah, as Rose wrote in the chat, if anyone has any questions, please use them, and she will use the chat and she will direct them to us. Okay, so in practice, using Python is growing rapidly, and you can see in the graphic below that it will be a very, very popular language in the long run as well, and people expect it to be a good investment into your coding skills to learn Python. Okay, so some differences that the three of us encountered in the first step when we were referring to Python versus other programming languages that we already knew. So the first thing is Python is case sensitive. So a lowercase hello world is not the same as a uppercase hello world. Python starts counting, for example, within iterations, lists, and other things at 0. So this is important when you want to access a certain value saved within a data structure. So if you want to have the second one, it will be 1 and not 2. And blocks in Python are defined by indentations. How we kind of referred to when we were discussing the presentation is that Python is very beautiful because of its indentations, because you have an in itself structure already implied when writing the code. Okay, so the first steps within Python. Your first program. If you want to print something, you just write print, put it in parentheses and in those inverted commas, and then it will print it. That is very easy. Python in itself is very easy in its basic steps. And one of those basic characteristics is that it can be used as a simple calculator. Here you can see that you can use Python for adding up things. You can even have more complex expressions. You can have float division, integer division. You can use exponential expressions. But then you can also do some more interesting operations. For example, finding the absolute value of a given number. So for this, you just use the apps function. This is a function that is preloaded within Python, so you don't need to do anything else. You can just start running Python, print apps, and then whatever number you want, and then go for it and print it. Obviously, the absolute value of a positive number is also a positive value. And then you can also convert between units. So if you want to define something, you can just print it out. You can find that something is minutes or something is hours. And then the output formatting is something that is inherently very Pythonic. So we put a link in here that you can make, that you can refer to, make sure that if you want to print something, it will actually print it the way you want it to. So it will print it in a layout that is specific to Python. In this case, you can just tell it, give it the minutes in those curly brackets, equal the hours in the curly brackets, and then it will refer to the two values. Then something else that is very interesting is that we can find the minimum and maximum in a list of values just by the min and max function with preloaded. But then if you want to do some more statistical stuff, we can use the built-in statistics module. It is built in, which means that you don't have to actually download it in addition, but you have to put the import command in there. So you have to tell Python, now I want to do the statistics stuff, please import statistics. This is a module, and I will refer to the modules, or we will refer to the modules later on. So there's a bit more onto that, but basically just write it down, and then you can use all of its capabilities. So you can just use the mean value, the mean function to find the average. Alternatively, you can also just calculate it yourself without actually using the statistics module. But I think it's more, it's easier and it's leaner to actually just use statistics.mean. And then of course you can see that it's the same thing. So that's the way to deal with modules. You import them, you refer to them, and then you can use the functions that are loaded with the module. Okay, so that's basically importing the first module. As I said, a module is a library of code that was written by some smart people in the Python community. And then, for example, there's also some other useful modules that one of them is called math. This enables you to have some logarithmic expressions and to also work with sinuses and pies, which is also just preloaded within the math module. And if you refer to this docs Python, which is the documentation of all things Python, you will find more information on the math module, as well as on any other module that you can just import like this. Then we have some data types. In Python, you can define, print, and calculate with variables. And those variables can be in very different data types. So integers, floats, complex numbers, strings, Boolean expressions, lists, tuples, and dictionaries. So let's quickly get over those easy ones. Of course, we have the integers, we have the floats. I think it's very neat that Python actually realizes that this is a float number and you don't have to tell it. Then we can use complex numbers. Here we use y to indicate the square root of -1. So you can make sure Python knows that you're actually referring to a complex number. Strings. Strings can be delimited by a single or a double quote. It doesn't really matter. And if you put, in this case, a floating number into quotation marks, it will also think that it's a string. So you won't be able to make any calculations with it like this. So take care. Then you can use the length function with the strings, tells you how long the string actually is. And then you have the in operator, which checks whether a substring is part of another string. So for example, hello is in hello world, which gives you the Boolean expression of true, and universe is not in there, so we'll get the Boolean expression of false. Boolean, true or false, it will tell you that. And then you have the Boolean negator. So basically, not something is the opposite of the value of the Boolean something. So in this case, if we defined B as true, not B is false. So we can have an optimization module in this case, where we want to use the potentials that the Boolean expressions give us. And we want to terminate the model when we reach a time limit or when we reach an optimality gap. We'd like to stop when we reach 100 seconds and when the gap is smaller or equal to 0.05. So basically, you will get from your model a value of the seconds that are spent and on the gap that is there to your optimal solution. And then you can write the following expression that you want to terminate if the seconds spent are greater or equal than 100, or if is smaller or equal than 0.05. And you want to print what the value of your terminate expression. It's not really a function, it's just a Boolean expression that is combined, what that is. So in this case, since the seconds spent are larger than 100, it will print out true. So basically, it will terminate in another step. You will still have to implement this, but it will have the potential to terminate your model. And in your file, you can obviously play around with the values to see how terminate changes. So for example, if both are not terminating it, then it will be false. If one of them terminates, it will be true. And if both of them are terminating values, then it will obviously also terminate. Then lists. In lists, you can type independently, store a sequence of items. You can put them simply into brackets and separate them by commas. So you can, for example, store integers, but you can also store a mix of different data types. So you have an integer, a float number, a string. You can just print it, you can just deal with it in any way you want to, as lists are type independent. Items in lists can be accessed by their position. So here again, you need to pay attention to the numbering of items in the list, which is the fact that numbering starts with 0. So for example, if we want to access and replace the third item in the list number 2, we need to refer to it as list number 2, 2. So instead of the integer number, we will put in test on the third place. Then we can also check if an element is in a list. So, but here you need to take care that if you have a long list, this can be very time consuming. So it will go over and over and over it again, and then it will be a bit of a mess. But in a short list, in this case, it's very quick. So is the expression Sirelt in our list? Yes. Is the number 15 in our list? No. The length function can also be used to count the number of the elements. So here we have a length of 3. We have 3 different elements of 3 different values and 3 different kinds. You can sort lists with the function sorted. However, obviously you need to have lists of integers or float numbers. You can't sort expressions. And then you can nest lists into other lists. So you can have a list be a part of another list. So you can just put it in here, 1, 2, and then the list number 2 form list number 3. So you can see here, it's again denoted by the brackets. And then tuples are lists that you cannot, that are immutable, and you surround them by parentheses instead of square brackets. So that's just basically another way of expressing lists that you don't want to change in the way. But most likely you will use lists instead of tuples. Then we have dictionaries that are like a dictionary in your normal life. It's a data structure that pairs keys with associated values. Each key can only appear once per dictionary. If you think about it, there will only be one word in German, for example, corresponding to a word in English, or one word in French corresponding to a word in English, and you won't find the word house twice in a dictionary. Dictionaries are denoted by curly brackets. So you can obviously generate an empty dictionary, which then will print out something that is empty in curly brackets, and you will see that that's the class. But then you want to fill the empty dictionary. So you want to say, hello, salut, summer, été, thanks, merci. I'm still learning. This is my level of French. And then if you print the former empty dictionary after you have assigned the keys with the values, it will say hello means salut, thanks means merci. So it will basically correlate, as I said, each key to a value, and it will place that within the curly brackets. And then of course, you can just print the keys and the associated values. So for each key and value in the items, so these are the items in the dictionary, you can print them, and then it will put out the whole list. And if it's a big dictionary, this will be a huge mess, but you can just basically get them. And if you want to just check what are actually all the English words that I put into my dictionary in this example, you can just print out all the keys. And if you want to check all the French words, you can put out all the values. So you can list all of them, or you can list them separately, whatever your use case might require. And then we can also check if your dictionary contains a certain key. So is hello in the dictionary, or is goodbye in the dictionary? So hello is in the dictionary, goodbye isn't. Obviously, you can also work like this with other types. You can also use floating point numbers or integers and put them into your dictionary if they want to correlate to something. But you need to take care that you always refer to them as strings, because that's how they're put in the dictionary in this case, because it's a dictionary. It's like letters. And then finally, the sets, similar to the ones we have in mathematics, we can just set up a set, and we can print everything that we see in there. So we can print just this whole list, and we can also print Boolean expressions where you, for example, say is 2 in my set, and then it will say true. You can then, since it works more or less the same as we have, or it's just the same as that we can draw in mathematics. So we can have a section or a difference, and it will print out what is actually differing the two sets. So here we have 3, 4, and 5, 6, and here we have 1, 2, 2 times the 3 and the 4. So if we unionize those, we will have all the numbers from 1 to 6. If we intersect them, it will be 3 and 4. And if we look at the difference, it's 1 and 2 because the others are within the set number 2. Yes. Then let's go on. The final thing that I will be talking about is the conversion between data types, because sometimes you might want to convert one data type to another, but you need to pay attention, of course. So if you change the characteristics of your variables, you will also lose some of the other original characteristics. So for example, if you look at this float number and you want to make it an integer number, so you put int of the float number, it will obviously cut off the 0.7. So you need to take care. If you want to round instead, you use the function round, which is also just a very basic function that Python has integrated in its calculator capabilities. So you can just round instead of cutting off your number, which depends on the use case, obviously. And then you can also use other conversions. So you can have a float number out of an integer. You can have an integer convert to a float, to a string, which can be very confusing. So make sure that you actually know that you're converting it, because later on, if you might want to calculate something with it, Python will be saying, yeah, what is your problem? I cannot calculate with it. This is a string. While if you print it out, only like print string number, you will get a 1, and you might think, yeah, it's a number, so why don't you calculate with it? So be aware of the types. And then obviously from a string back to an integer or a float. So you can just put whatever you want to convert it into in front, and then in brackets, you put the name of the integer or the string or the float, whatever floats your boat. Okay, now I will hand over to Gabriel, who will introduce you to the modules. I'll stop sharing. Thank you.
Thank you, Christina.
If Zoom allows me to stop sharing, it wants me to keep on showing you things. Can you just?
I think I can just share mine.
Can you?
Who can share your share?
Yeah. Ah, okay. Otherwise, you could just kick me out of sharing.
Do you see my screen?
Not yet.
Okay, let me try sharing again. Now I think it works.
It's here.
Okay. Hello, everybody. Thank you, Christina, again. So let's focus a bit more now on Python modules. So modules in Python are, like any other programming language, a library of code that was written by someone in the Python community. So it's the same as a library in C or C++ or a library in Java. And the nice thing about Python is that we usually call Python a language that has batteries included. It means that Python already has a lot of modules in the community, either built in the language or modules that are very easy installable into your Python distribution. So besides the built-in modules, you can also find modules that deal with data handling, plotting, statistics, text analysis. Lots of machine learning algorithms are already implemented in Python. And of course, we have modules that interact with commercial solvers like Gurobi and Cplex, which we will see in the next seminars of this workshop. So as it's a battery included language, I strongly encourage you to, before trying to implement something by yourself, use Google for 5 minutes to understand if there's a module that already does what you do in Python. For example, in my special case, I had the latitude and longitude coordinates, and I wanted to approximate the distance in kilometers between points. And I started to do the calculations by myself based on some formula that I found on the internet. But in fact, there is a module in Python called GeoPy, if I'm not wrong, that already has this implemented for you. So the less you code by yourself, the less the chances of introducing a bug, and the quicker you'll have your experiments ready and have your publications already. So use modules. So how to install modules in Python? It can be very simple. So to install a module in Python, you can just write pip install and module name. Pip is the Python package manager. So you're telling it to install a module named module name. So for example, if I want to install numpy, I would write pip install numpy on your terminal. And that's it. That's what you need to do. But for most cases, this works. But be careful, because for some modules, depending on how the module was implemented, it can be a bit tricky to install a module. And depending on how your Python distribution was installed into your computer, it can be also a bit tricky. So if the module needs access to GPUs, or if the module was originally implemented in C or C++, it can be a bit tricky to install it. For example, Gurobi and Cplex modules are not that trivial to install. So I refer you to the Python documentation to learn a bit more on how the installation of modules work. But overall, 99% of the time, you will just do pip install module name. So once you have installed your module, you can just import it using the import command into your Python program, and you can start using it. So here's an example for the numpy module. So the numpy module is a very famous module for scientific computation, and you can just import it by writing import numpy. And here we have an example where we call the function numpy point degrees. This function converts radians to degrees, and I'm passing as a parameter the constant pi, which resides inside numpy. So this will convert pi radians to degrees, so we have 180 degrees. Now, numpy is used a lot. I use it all the time, and it has all sorts of useful mathematical functions. So you will find yourself very often writing numpy, numpy, numpy in your code. So something very common in the Python community is to abbreviate module names if you use it a lot. Otherwise, you'll have to write numpy every time you want to call a function inside this module. So something that is very standard in the Python community is to abbreviate modules. And for the numpy case, we can abbreviate it to np just by writing import numpy as np. So instead of calling it numpy, when I write my code, I will just have to write np point degrees, np point pi. For pandas, it's the same. We usually import it as a PD, import pandas as PD. So for most codes on the internet that use numpy or pandas, you'll see an abbreviation like this. Now, not only you can abbreviate modules, but you may want to use only specific parts of a module, and maybe you want to import these parts into your global namespace of the program. So let's say that I want to be able to use the function degrees and the function pi, the constant pi directly. You can do this in Python by writing from numpy import and then the list of things you need from this module. So you don't have to write np point degrees anymore. You can just write degrees, and the same for pi. This can be useful as your code can look cleaner, but be very careful when doing this, because this is bringing things that are outside your project into the global namespace of your project. So this may overwrite your local functions and variables. So only use this for things that you're really sure that you are going to use a lot. So I want to give an example now of a very powerful module that is already built in Python. It's the datetime module. And that's a very nice thing about Python, that it deals with dates out of the box. And for us that work in OR, this can be very useful when we have optimization problems that have time windows or time-dependent features. So usually I generate my instances and I have time windows there, but all the time windows are actually dates in my textual file because it's easier for me to read. But when I give it to a computer to read, I need to convert these dates to numbers. So that's where Python comes as being a very useful language. I can easily convert these dates to numbers. I believe that it's not that easy to do it in C and C++. I did it a few times, but I had to import libraries that were not already in the language. And I believe that in Java, you can deal with dates out of the box, but it's not as nice as Python. So here is an example where I import the datetime module, and I want to know what is the current datetime. This will give me the date and the hour, minute, and second for the present moment. So when I executed it, it was 2020, November 18, 19 hours, 12 minutes, and 9 seconds, and you have lots of precision on your seconds here. And the nice thing is that now is a datetime object, and I can perform date arithmetic on this object. So if I want to see what is the datetime for tomorrow, I can sum to now a time delta of 1 day. So I specify datetime, point time delta, days equal 1. And if I want to see yesterday, I can sum to now a time delta of -1 day. So when I print tomorrow and yesterday, you can see that they are now plus 24 hours and minus 24 hours. The hour, minute, and second are the same. Not only that, but I can make a subtraction between 2 date times. And this will give me a time delta. So I want to know the time delta between tomorrow and now. And I save this result in the variable delta. And this will give me the amount of days, hours, minutes, and seconds between tomorrow and now. I print this in the last line here. The days between now and tomorrow is delta point days, and it's 1. And not only regular arithmetic, you can also test Boolean operators in your date times. So for example, I can check if now comes before tomorrow by writing now less than tomorrow, and the result is true. Now comes before tomorrow. And I can also check if now is less than yesterday, and the result is false, because now is actually after yesterday. So this is all included in the datetime module, and this can really simplify your code and avoid you repeating yourself and implementing stuff that is not directly related to your project. Now I want to talk about conditionals in Python. So conditionals are how you make your program execute different stuff based on the values that your variables have. And in Python, you write conditionals with the if, else, and elif statements. So here I have a simple example of if, else. I have a number that has value 7, and I check if the number rest of division by 2 is 0, then I print number is even. And recall that in Python, the indentation defined block. So it's not like C++ and Java where you have square brackets. Here, this space between the start of the text and the print statement defines that the print statement is inside this if. So Python forces your code to be beautiful. This is a thing that I really like in the language. So if this condition is true, I will print that the number is even. Otherwise, I'll print that the number is odd. And as this condition is false, it will print number is odd. You can also use an elif statement. The elif statement is just else and if glued together. So if you want to have multiple conditions in your if-else block, for example, we have a bank system example here, and I have a deposit operation. First, I check if the operation is withdrawal. If it is withdrawal, I ask how much you like to withdraw. Else, if the operation is deposit, I ask how much you want to deposit, and otherwise I print an error message. So as our operation is deposit, the first condition will be false, so I'm not going to enter this block. Then I go to this elif, and this condition will be true, so I'm going inside this block, and that's it. I don't check the else. And we'll print how much you like to deposit. You can also put complex Boolean expressions inside your conditionals. So let's say that I have a number and it's 10, and I want to test that the number is odd, but not only that, I want to test that the number is greater than 6. So I can write this complex Boolean expression here with AND operators or operators, whatever you want. So this condition here will be true, and this condition here will be true as well. So the program will print this message: number is even and greater than 6. And something very nice about conditionals in Python is that you can write expressions like this to check that a number is in a range. So 3 less than or equal to x, less than or equal to 10. So just how we write in mathematics. And so, for example, I have a variable here that is equal to 5, and I want to check if it's between 3 and 10. I just write if 3 less or equal x, less or equal 10. And if this is true, it will print that x is in this range, and it does. If you want to do this in C++, you have to write the two conditions separately: 3 less than or equal to x, an AND statement, and x less than or equal to 10. So Python really simplifies this kind of expression for you. And of course, you can nest conditionals. So any valid Python code can be put here inside the if block, and you can put more if statements inside. So let's say that first I want to check if the number is even, and I'll print number is even if it is. But I also want to check if the number is greater than 6. And in this case, I will print also number is greater than 6. So at first, my number is 10, and this condition will be true. So my program will go to this line and print number is even. And then it will check for the other condition, number greater than 6, which will be true again, and will print this message. So the output has 2 lines. But if my number was 6, for example, it will still be true for this condition. So it will print number is even, but this condition will be false. So the output will be only number is even. Okay, now I'll talk quickly about iteration. So in Python, you can perform iteration either with the for statement or the while statement. And the for statement is a very simple way to iterate over a list of values. It's the most commonly used loop iterator in Python. You don't use while a lot. And here's a simple example on how you can use the for statement to iterate over a list. So we have a list of 3 values, and we write for x in L, and x will assume the value of each position of L in this loop, and I can print x. So we have 1, 2, and 3. If you want to use while, you can write an equivalent program with the while statement, where I keep the current index for each position of L, and I'll have a while that will repeat until I reach the end of L, and then I'll print L at its current index, and then I'll increment my index with plus equal. Python doesn't have the plus plus and minus minus that C and Java has. It only has plus equal and minus equal. Now, what really cool feature of Python is list comprehensions. I am not aware of any language that has it. List comprehension is an easy and compact way to create lists, very similar to how we write set notation in mathematics. So for example, you can see this expression here. L is the integers between 0 and 10, such that x is even. You can write something very similar in Python, which is shown in this block here. So you write L, square brackets, x, for x in range 10 plus 1. This will give you the numbers between 0 and 10. If x% 2 equals 0. So this will filter all these numbers and will give you only the even numbers. So 0, 2, 4, 6, 8, and 10. And you don't only have list comprehensions, you also have dictionary comprehension. So you can build dictionaries with the same notation, but with curly brackets here. So let's say that I want to create a mapping, for example, from x to x squared. So here, between the 2 dots, before the 2 dots, I specify the value of my key, and the value is x. And I specify the value of the dictionary after the 2 dots, it's x squared. So the mapping is from x to x squared for x in range 4. So this will generate the mapping for the integer 0, 1, 2, and 3. And of course, you can put an if block by the end of the dictionary comprehension. So if I print all keys and values of my dictionary, The first column is the keys, the second column is the values. So you see that it is squaring 3 to 9. Okay, now I'm going to talk about defining functions in Python. And you can define functions very simply in Python, and they can receive one or more parameters, and they can return one or more values. So you define functions in Python with the def keyword for define. Then you specify the function name, multiply, and the parameter list. So here's a function that receives two numbers and returns the multiplication of these two numbers. Python is a dynamically typed language, so we don't specify the types here. So if I call multiply 10 2, this will return me the number 20. And here I show a function that returns multiple values. So let's say that I'm giving two numbers, a pair of numbers, A and B, and I want this function to sort this number. So I have the sort pair function, and if I call sort pair 10 and 5, I want it to return me 5 and 10 in this order. So what I do here is an if-else block. First, I check if the pair is already ordered, A less than or equal to B. If the pair is already ordered, then I just return the pair itself. Otherwise, I just swap the elements of the pair. So I save the result of this function into a variable called result, and I print the result, and you can see here that it is in fact sorted. And if I print the type of result, you can see that it is actually a tuple. So that's how Python functions can return multiple values. Under the hood, this is actually a tuple when you separate values by comma. You can also define recursive functions in Python very easily. So let's take, for example, the Fibonacci series. To remind you quickly, the Fibonacci series is a series that the first and second element are 0 and 1. So fib of n is n if n less than or equal to 1. And otherwise, the nth number of Fibonacci is the sum of the previous two numbers. So we can very easily transform this into a Python code by writing def fib of n. Then we check for the base case, so n less than or equal to 1. If this is true, we will return n. Otherwise, we will return fib n minus 1 plus fib n minus 2. And this will call the same function recursively. So if you call fib of 10 here, our result will be 55. You may have noticed that I put a string here that basically describes what the function is doing. And I will explain this on the next slide. So Python has a function called help. It's basically a function that helps you to understand better how the documentation of other functions. And the string that I put here is actually called a docstring in Python. So it's a string that defines the documentation of a function. So when you call the help function on any function, it will read the docstring of this function and show to you. So I call help of fib here, and this shows the same text that you saw on the previous slide. Returns the nth number of the Fibonacci series. And of course, I hope that when you write docstrings, you write a better documentation than me, but you don't only use the help function for your own functions, you can use it for the functions that are already in Python. So you can learn more about building functions, for example, by calling the help of print. And we can learn much more about what the print function can do. For example, we can take a file, you can specify the separator between values that you are printing, you can specify the end character of the print function. By default, it is a new line, and you can tell the print function to flush or not the screen after printing. So I encourage you to call help anytime you want. And in fact, the official Python documentation is the official Python documentation is generated based on the docstrings of the functions. Okay, now to finish, I'll talk quickly about anonymous functions. Anonymous functions are very simple and one-line functions that you can define, for example, to filter or to map values. So here you have a list of values 1, 2, 3, 4, and you can check you want to filter only the even values of the list. So you can define lambda x is your anonymous function that takes one parameter, and you check if the number is even. And you pass is even L to the function filter, and it will give you only the even values of the function. So anonymous functions can be used when you need to do data transformation, and you need very simple conditionals to your very simple conditional criteria to pass to filter and map. And here we have another example for the map function that we want to square each element of the list. So we have a square equals lambda x, x squared. And we pass the square anonymous function that we defined and the list L. So if you see the result of map, you'll see that it is mapping 1, 2, 3, 4 to 1, 4, 9, and 16. So I strongly encourage you to learn more about anonymous functions because it's a way of very simply expressing data transformation for your program. And I think I'm done here, yeah. So I'll pass the word to Weiku. Thank you, everybody.
Thank you so much, Gabrielle, for the awesome presentation and handing it over to me. So I'll try to share my screen now. Let's see if it works. Can you see it?
Yes.
Yes, perfect. Thank you for letting me know. Awesome. So now that we've talked a little bit about some modules and what they're useful for, in my part, I'm just going to add on top of that, basically. I'm going to talk about some additional modules that are probably interesting to people who are working in optimization or operations research. And the first one is actually going to be the random module. So this is also, I have to make a disclaimer here. So the modules that I'm going to speak today are not the only ways of going about generating numbers or doing any of the things that I'm going to explain. They're just examples of what you could use if you want to basically do these things that we will talk about today. And I'll also give you some alternatives, some alternative modules that you could use that do more or less the same things. And some of them have functions maybe that are more useful to you because at the end of the day, it really depends on what your research needs are, what you're trying to do. So basically, it's just a good thing to keep in mind. So the random module is great because it's a built-in module and you don't really need to install it from an external source. And you can just basically say import random at the very beginning of your code, and that will just do it. And you will be able to use all the functions within this module once you have this line 64 at the very beginning of your code. So once you import this module, you can now generate random numbers. So let's just look at a very, very simple example to just start things off. Basically, just like what we've been doing before, we're going to use the same syntax where we put the name of the module first, followed by a dot, which is then followed by the name of the function that we're wanting to call. And in this example right here, we're basically calling the function uniform from the module random. And this function uniform takes two inputs or two arguments, which basically defines the minimum and the maximum value our number can take. So our variable num can be any value between these two numbers. And in this specific example, our random number turned out to be something like 0.37 all the way to so many decimals, all the way to 56. And oftentimes your random numbers will look pretty specific, I think like this. And sometimes you might want to make things simple because it looks pretty specific, like I said, and then you might want to round it up to a certain value or a certain number of digits. And to do this, we can use this .2f notation that we have in the second line here, and that will just make sure that we have two decimals instead of so many more decimals, which can be a simpler way of using these numbers. Okay, so when we're generating these numbers, sometimes we might want to generate integers instead of continuous numbers. These are often useful in cases when we want to generate instances maybe that only take integer values, or maybe you came up with a dynamic program or some kind of algorithm that only works if a certain number of or a certain type of inputs are defined as integers, and you want to test maybe what happens if you have certain inputs to your problem as integers. And in those cases, you can just basically use this function right here. And it's very similar. The syntax is very, very similar to what we have looked at before. So it's still the same thing where we say random dot the name of the function, but this time we're using the function randint instead of uniform to return an integer number instead. So the arguments and the inputs to this function will look very similar as well. So the minimum value I want my integer to be is a 0, and I want the maximum to be 10. So Python can return anything in between these two values to me, and in our example, it turned out to be 9. So yeah, num took the value 9. And we can just repeat this, of course, as many times as we need, depending on what our needs are. Okay, so another example is to sample from a distribution. In this case, for instance, let's just look at this Gaussian distribution example that we have here. We're still following the same syntax where we have the name of the module followed by the name of the function. And for the Gaussian distribution, we can use this Gauss function, which again takes two different arguments. But this time, since this is a distribution, the arguments might look different, again, depending on what kind of function you're using. And for this specific case, we have to specify the mean and the standard deviation of the type of function that we're using. And these are exactly what those two values are. So 5 will be the mean of this distribution, and 1 will be the standard deviation. And this will just return you a random number that belongs to this distribution, basically. So if we call this variable num, we will see that our random number turned out to be something like 4.933, again, all the way to 87, very high precision yet again. Okay, so sometimes we will see that it will be more useful for us to generate a list of random numbers instead of only like one random number, right? This is often the case when we want to have an instance generated, because it is very likely that you might have read in some paper at the very end in the computational experiment section, they often say something like, we generated these instances, right? And this is where this will come in handy. So you might want to generate a list of random numbers, so multiple numbers at once that belong to some kind of distribution or that follows some kind of structure, depending on, again, what your needs are. And this can just be very flexible, again, what you're trying to do based on what your research is about. So let's just look at this random example in the random package, which has to do with, again, generating a list of random numbers from a Gaussian distribution. So we're using the list comprehensions here, just like what Gabrielle was talking about in the previous section. We can basically show and initialize our lists in this manner, basically. And for this specific example, we're trying to generate 10 different values that belong to this Gaussian distribution function, which is, again, if you look at this left-hand side that comes before 4x, it is exactly the same as what we were doing here. So to generate a single number, we use this thing, random.gauss51, and we're again using the exact same thing, but the only difference this time is that we're repeating it 10 times for every single value in this range of 10 numbers, which is going to be 0 all the way to the 9. And x is just a variable to basically iterate over that range of values that we have. And every single time x is repeated for every single value in this range, our code is basically going to execute this thing over here, this expression. Which obviously results in something that looks like this. Again, every single number that we have just returned using this will be a number that belongs to this Gaussian distribution that you've specified earlier on. So if we print our list, we'll find that we have all of these values. Again, there are 10 of them, since we've specified this to be a range of 10. And sometimes it's a good idea to maybe look at some statistical features of what your random numbers have. So statistics is a good way of doing this. It's another module that you can import. It's a built-in module. So you can just import it and then call it inside your code if you want to learn more about what your generated numbers are like. So for instance, this list has a mean of 5.32 and a standard deviation of 1.33. And this is very nice to see because we have actually defined it to be very similar to these two values. So we can see that the mean is very close to what we had defined, and so is the standard deviation. So this kind of says, yes, we're on the right track. Everything looks more or less like what it should like. Okay, so an important thing to keep in mind when we're generating random numbers is that every time you execute these lines that involve a random function, the value that will be returned by Python will be different, or will most likely be different, since these are generated from random seeds. So if you're wanting to reproduce your experiments, or if you want these numbers that you've generated to be used later on, you will somehow need to store them, or you can also decide to look into the concept of random seeds and how to reproduce values from that. And the rest of this part that I am going to cover, I'm going to look at the first option where we can write these values into a file and then read them from another file later on. This can be useful for cases when you want to maybe share your instances with other researchers in the field. If you're trying to create a benchmark instance or a set of instances that will be benchmarked hopefully later on, then it can be useful for that. And it's also important to keep in mind, again, that you can use other packages and other modules for these purposes. And numpy is one of them. And as we've already covered as well, numpy is widely used in this area, in maths and statistics and random number generation as well. So definitely check that out. And the number of functions and range of functions that is available through numpy is just extensive. So it's definitely worth going in this link and checking it out after the workshop so that you can have an idea of everything that you can do with this package. Perfect. So this brings me to the sort of last thing that I will talk about, which is writing and reading data. This is an important concept for all the reasons that I've already just talked about. It's just very nice to be able to look at your data sometimes. Maybe you want to analyze your data later on and you want to just keep it somewhere so that you can access it later for whatever analysis purpose that might appear later on. This is something that I have also used a lot during my research. I've written the data that I've worked with, and this allowed me to maybe switch between different programming languages, or switch between different computers, or share my instances with other researchers in the field. So it's really useful in that regard. The specific package that we're going to look at is JSON, but just like before, this is definitely not limited to this package that we're going to cover here. There are many other options that you can use that do more or less the same thing, so definitely check those out, and I'll talk about them at the very end as well, just to give you an idea. Okay, so when we're trying to write into a text file, of course, the very first thing we need to do is to tell Python what our file will be called. So let's just define a variable called file name, and let's just name this output.txt. And one thing to be careful about here is that oftentimes you will need to put this extension .text inside this string that you define here. And this is to tell Python what kind of file you're trying to generate, basically. And it's important because if you miss this, things can get funny, and we obviously don't want that. So definitely make sure to put whichever extension that you're working on at the very end of the variable where you define the file name. Okay, and let's say that we have some kind of that we have generated inside our program, and we want to somehow store this in a file called output.txt. Then we can use a syntax that, or a line of code that looks like this, basically. So my list is just a list of 3 numbers, and we want to store this again in this file called output.txt. So the first thing that I need to tell Python is, again, which file that I'm trying to write into. And to do this, we will have to first open to the file in a manner where Python will first create the file and then be ready to write into that file. And this is exactly what this open file name and the argument w is doing. So it's telling Python, hey, could you please open this file called output.txt such that I will write stuff into it. And just like we were doing it before, you can aberrate this if you want as well inside this with block as f, just to make things a lot simpler, just so you don't have to repeat this entire thing multiple of times. And you can just say, with this open file that I have, I want you to write some stuff into it. It's exactly what this write function is doing. And inside this write function, you have to tell Python what you're trying to write inside this file. And since we're using the JSON module, we can use json.dumps, again, which calls this dumps function from the JSON module. And what you're trying to write into this file is exactly what the argument of this function will be. So I'm trying to write this mylist list inside this file. And this is exactly why we have this mylist variable right inside the argument. Okay, so now that we've written into a text file, we can also read stuff from a text file. And the syntax will look more or less the same, but this time with a couple of small differences that will make a big difference later on. So since we're not writing into a file anymore, we don't have this argument W here when we're reading stuff. So instead we only have the file name, which we're again going to open. And we're going to abbreviate it as F, just like what we were doing here before when we were writing into a text file. And we're going to call JSON one more time, but this time instead of using the function json.dumps, which again was to write into a text file, we are going to use the function load, which is going to load the contents of this file that you've just opened inside your variable, which is the variable called mylist. So if you just test things out to see if everything works, we can just print this list that we've just created and that we've just assigned the values of file name into. Then we can see that this list is exactly the same as what we have written here, right? So this means that everything is working perfectly fine. So that's a good sign. And the same warning goes for reading from text files as well. Don't forget the text extension where you're defining the file inside this file name variable. Because then things can get a little funny and we definitely don't want that. Okay, so just like I said before, these are obviously not the modules, like not the only modules that you can use for these purposes. And the pickle module is an alternative to read and write different content into files and read from these files. But things look a little different for pickle because the file that you write into is a different format of a file. It's a binary file that basically will have the contents of whatever you're trying to write into it. But it won't be readable. So it's only readable inside Python, and it will be able to read this file using the pickle module yet again. So we have similar functions that look similar to the JSON function, just like the dump function and the load function. But again, the only difference, or the main difference, is the formatting of this file that we're using, and the extension .p as well is a difference from what we were doing before. So maybe depending on your needs, this might be a better way to go about it, or maybe you might prefer JSON if you want a readable file, and if you want to maybe access it later on, and if you want to see the contents of your file later on, maybe that will work better for you. So just like before, we can basically dump anything into this file as we want. So this can be a dictionary, for instance, just like this. So we have this great dictionary right here, which includes 2 keys and 2 values. And we can just dump this object right into the file and then read it again using the dump and the load functions. And if we print this, we will then have the function, which is basically what we had initially. So this is also a good sign showing us that everything works fine. Okay, so I think this is sort of like everything that we have talked about so far, the modules and the useful things regarding your optimization and operations research needs. So now let's just go over some of the modules that might be useful for you later on. So numpy, of course, we've mentioned this a couple of times by now. I've mentioned it, Gabrielle mentioned it a couple of times. It's definitely worth checking. There's lots of mathematical functions that you can use. There's lots of statistical functions that you can use, random number generation functions that you can use, so many things that are so useful. So definitely worth checking out. And the second thing that we wanted to say was pandas. So this is going to be a dedicated part of our workshop later on as well. So if you're interested in maybe reading and analyzing data with pandas, it's probably a good idea for you to tune into that part of our workshop as well, because we're going to look into the details of how to use data frames and how to use pandas to analyze these different forms of data that we have. And a good thing actually about pandas is that you can read from Excel files and text files as well. So definitely worth checking in with that. And Another package that might be useful is stats models. So it's really good for performing some statistical tests. So if you're more interested in maybe statistical things, this package might maybe answer your needs if you haven't found the answer to it in NumPy or in another module. Another one is ice cream. So this module helps with debugging, and debugging is an essential part actually of our Python needs, I think, because when we're writing codes, it's very likely that there will be some kind of bug that we will have to take care of later on. And packages like this will basically just make your job easier at the end of the day by just displaying everything in a more understandable and a more intuitive way. And it's definitely worth checking out for that specific reason. And of course, another thing that's important is to plot our results and to plot our analysis. So matplotlib has a basic plotting range of functions. Basically, it's a library that has things like, you know, bar charts, pie charts, line charts, scatter plots, and so many other things. Likewise, Seaborn is an alternative to this if you also want to maybe check that out. So all the links, by the way, for these, as you can see, are available. So after the workshop, if you're interested, you can go into every single one of them and see which one works for you if you want to learn more about each one of these. So for all the machine learning folks out there, there are several modules that you might find useful as well. So different algorithms in machine learning are available through these 3 packages that we have. sklearn is a very popular one. GenSim and TensorFlow or other alternatives to this. And of course, if you want to include great emojis in your presentations like we have, you can also use this or in your codes, I think. Yeah, that's another thing to keep in mind. There's more additional information about everything online. So this is something that I specifically wanted to highlight because oftentimes it is very likely that we haven't covered something you specifically need for your code. And this is exactly when these links will come in handy. So you can just go online and search for the specific function that you're needing and then read the documentation for that. This always just solves most of the problems. And like we've said, since there are many people out there that are using Python, it's very likely that you will find an answer to the specific problem that you're having. And there's also a couple of articles and a couple of websites that you can visit to learn more about Python and why you should use Python. Okay, so this sort of summarizes the sort of teaching or the talking, the presentation bit of the workshop. And now we're going to move on to the exercises bit. So this is a great opportunity for you to test out what you have learned today. And if you want to maybe follow along with these exercises. So a disclaimer again to make here is that some of the things that we've included in these exercises might not be super easy and intuitive to follow based on what we've just taught you. So it's important to be able to search the internet for your specific needs and your questions. And like it has been mentioned before, Stack Overflow is going to be your best friend when it comes to this. So go on Google. It doesn't, by the way, the questions that you put on Google don't have to be perfect by any means. So if you just put in some of the keywords that you're looking for together, you don't have to phrase it perfectly. Probably the first or the second thing that you will see is going to be some person posting something on Stack Overflow that is exactly what you're looking for. It's very likely that this will happen. And the more you do this, you'll see that the phrasing of your questions and how specific your questions are will also be better over time. So you will learn how to sort of phrase the questions and look for the answers for your questions better over time as well. And I think this is a very important thing to learn because I can easily say that I've learned a huge chunk of my knowledge in Python and in any other language really on Stack Overflow. There are many helpful people out there. It's kind of like a forum, maybe you've already seen it. So yep, it's just a good thing to keep in mind. Okay, so I will quickly walk you through the exercises and what we're trying to do actually in the exercises before I hand it over to Rose. So we have 3 different exercises for today. The first one is going to be a knapsack problem. And we are, by the way, we wanted to keep these exercises more operational research-wise, just so it kind of answers your potential needs in the future. So this first exercise is a case where we have a bug in our code, essentially, where we made this basically model. We have implemented it. We're just assuming all of this, of course. We have implemented it. We have a solution to this, but clearly the solution is infeasible, as you will see in the explanation here. And since this is an infeasible solution, we want to know why, and we want to kind of understand and code all of these steps that you will read through on your own in a second, which will return basically whether the solution is a feasible one or an infeasible one. So this is just a good way to sort of exercise how you can write iterables, how you can write for functions, how you can write lists, how you can initialize variables, so many different things inside each one of these steps that we thought would be useful for you. And this one is basically just an extension of the first exercise. So if you make a couple of changes maybe to the exercise, to the problem, to the original problem, what will change is basically what we're looking at here. So the changes to the model and how your code will change accordingly is what we're going to look at in the second part of the first exercise. So the second exercise is kind of similar. So we have like a supply chain problem for the second one, and we have different suppliers and different times and different optimal order amounts that we have again solved the problem for. So we're assuming that we already have the Cplex, the Groby sort of implemented in our program for this one, since we haven't learned how to do this yet. So we have a solution that, again, we would like to understand more, and the second exercise kind of focuses on this. Again, it walks you through how you can initialize some of the variables and how you can maybe just initialize dictionaries or assign keys to these dictionaries, and how you can amend the values in these dictionaries, and how you can filter certain things out. So it's just a good way of understanding these different sort of types of data types that we have in Python. So the last one is the try at home exercise, because probably we will run out of time, I believe, by the time you get to the third one. So this is just an instance generation example. It's really simple. And it just asks you to generate some of these parameters that we have available inside this lot sizing problem. It's a very basic problem, again, only with 10 time periods. It's a really tiny, small one, just to make things simpler for the first step. And yeah, it will again walk you through every single step that you need to just implement to have these instances generated. Okay, so once you have generated these instances, you can also try to read them back into your code and see how you have performed. And this is the entire point of this third exercise. And I think that concludes everything I have to say about the entire thing. So thank you so much. And I'll hand it over to Rose.
Thank you, Oiku. Thank you, Gabriel. Thank you, Christina, for your presentation. So now it's the moment where we get to have fun, meaning that as advertised, this is an hands-on workshop. So now you'll get to actually use Python and see, you know, if you are paying attention or not, or if you can actually get to Google things and do it correctly. So for starting now, we're going to stop recording because the hands-on part will not be included in the recording of this video.